Okay, in the previous video, I mean in the beginning of the class, if you still remember, in the first meeting or the second meeting, we have discussed about the domain and the range, okay, for the two function of variable, which is z equal to fxy. Okay, so we have looked at the domain, okay, and the range. Okay, so now I want to show you the relation, okay, between the domain, the range, and also the graph, okay, that we have sketched for the two variable function, okay, here. Okay, so since we already looked at the sphere and the semisphere, okay, so I want to show you about the domain and the range for the sphere and the semisphere. Okay, so now you have the equation for the sphere before, right, which is what is it, z squared plus x squared plus y squared equal to 9, right? Okay, so in order to find the domain and the range, of course you need to make it in the form of z equal to fxy, right? So you need to rearrange this and you need to obtain that z squared, okay, 9 minus x squared minus y squared, and z here, okay, so this time you already rearrange. If you rearrange here, so here is z squared, so meaning that you need to consider that plus and minus. Okay, you need to consider plus and minus because the original is here. Okay, we don't know what is the value for z. Is it negative or is it positive? Okay, so basically you need to consider both positive and negative value. Okay, alright, so now, okay, so we need to determine the domain. Okay, the domain for this one here is, okay, so let's, okay, alright, so the domain, okay, for this one is basically for in term of x and y. Okay, so we know that all the x and y are all real number, and we need to consider the restriction, isn't it? The restriction for the function here. Okay, so what is the restriction? Since it is square root, okay, so we know that the square root for the real number must be greater or equal to 0. Okay, therefore you will have 9 minus x squared minus y squared greater or equal to 0. Or basically you can rewrite it as x, y. Okay, so since it is in this form, you can also write in x squared plus y squared, which is less than 9. Okay, so you know that this is a circle. Alright, so this is a circle. Alright, okay, so now you can sketch it. Okay, so okay, so x squared plus y squared, so it is in the x and y axis, okay, with the radius of 3. Okay, so this is your domain. Okay, this is less than 9. Okay, so it's inside lah. Okay, so 3 minus 3 minus 3, 3. Okay, alright, so now let's look at the range. How about the range? How you want to determine the range? Okay, so the range is you need to refer to the output, right? So the output here. Okay, you need to know what is the value for the z. Okay, so you know that the z here is equal to plus minus 9 minus x squared minus y squared, right? Okay, so you know that for 9 here, okay, so it can be, if you can rewrite, it can be x squared plus y squared, right? Okay, so x squared plus y squared is always positive because both are squared. So the minimum value for this one can be 0, right? And it can be 1, it can be more than that, it can be 9, it can be 10, and so on. Okay, so now we can test for this value. Okay, so if we substitute the value, for example, 9 minus 0, okay, let's say lah x squared plus y squared is 0. Okay, so okay, so I just write it here. Let's say when the value for the x squared plus y squared is 0, okay, so you will have z equal to 9 minus 0. Okay, so of course you will have plus minus 3. Okay, so let's say you have 1. Okay, so the z value will be plus minus 9 minus 1. Okay, so it will be 8, okay, which is less than 3 lah. Okay, and then let's say you choose 9. Okay, so you'll have z is plus minus 9 minus 9, which is 0. Okay, so let's say you choose 10. Okay, so if you choose 10 and bigger than that, of course you will get since we only consider the real number, so of course you will receive a value of does not exist. Okay, or if you use the calculator, of course you have the method error. Okay, so meaning the value is does not exist in the real number. Okay, because and so on lah. Okay, because we only consider x and y in the real number. Okay, so now for this case you will have the value of plus and minus. Okay, so basically you cannot say that the domain the range, okay, the range for the z is between 0 and 3 only. Okay, so we know that the maximum value is 3 and the minimum value is 0, but you need to consider also the negative one, okay, which is the set 8 also in between the 0 and 3. Okay, the 0 and minus 3. Okay, therefore, so this is wrong. So what you can do here is the range. Okay, so the range for this graph is basically for the z, for the z output is from minus 3. Okay, and then until 3. Okay, because we need to consider for the maximum is 3, the minimum is minus 3, and in the middle is 0. Okay, so that is the range. Alright, okay, so now if we look at back the graph for this 3D, okay, so if you can have the 3D graph, okay, so if you still remember the 3D graph that we have sketched before, alright, x, y, z, okay, so if you still remember, okay, so it is okay, so it will be like this. Okay, so what is the relation? Okay, so now here is 3 minus 3 minus 3, 3. Okay, so basically what we can say here is, alright, okay, what is this? Okay, this is the domain. Okay, the domain is basically refer to the z axis here. Okay, so basically is when you are at z axis, and when you looking down you can see the domain. Okay, so basically this one is this. Okay, this one here. Okay, how about the range? Okay, so this is the domain. Alright, the domain. How about the range? Range is for the z. Okay, is for the z. What is the range for the z? The z is, the maximum value is minus 3 and the minimum value is minus 3. That is the range. Okay, so now you can see the relation between the domain, the range, and the graph 3D that we have sketched here. Alright, okay, so now I want to see about the second part, which is the graph of semisphere. Okay, you have z equal to 9 minus x squared minus y squared, set everything. Okay, so for this case you only consider positive part. Okay, you only consider positive part because it didn't mention about the negative part. So therefore from here you need to determine only the negative part. Okay, so what you can have here is, alright, so you have the domain. Okay, so what is the domain? Of course, the restriction. Okay, so you already know. Okay, so this is the restriction for the square root. Okay, so you'll have 9 minus x squared minus y squared, which is greater equal to 0, or as I said, you can rewrite as x minus xy for the xy. It can be x squared plus y squared, which is less than 9. Okay, which is a circle. Okay, so you can sketch this one is circle lah. Okay, so which radius of 3 minus 3 minus 3 3. Okay, for the x and y axis. Okay, so this is your domain. Okay, how about the range? Okay, so for this range, okay, so we have looked at the previous video. Okay, for this here. Alright, so we need to look at the output. Okay, output for the z here. Okay, since it's only positive, okay, so we know that the maximum value will be cert 9. Okay, and then the minimum value is 0. Okay, so the range for this case will be, okay, so the method is same as the previous example, just this one we consider the positive. Okay, therefore we will have for z, sorry, this one is z, yeah, because it's a range, so z. Okay, so we'll have the z is between, okay, 0 and 3. Okay, alright, so what happened is, okay, so if we look at the 3D graph, okay, so if you look at the 3D graph, okay, that we have sketched it before, sorry, here is x, yeah, consider is x, here is z. Okay, so we have sketched it before. Okay, so this one here, okay, so we have a circle, okay, and then, okay, this one. Okay, alright, so hopefully my sketching is so bad. Okay, so basically, okay lah, okay again. Okay, alright, so it will be a circle first. Okay, so let's me sketch this. Okay, and then you will have, okay, and then you have this. Hopefully you can understand. Okay, hopefully you can imagine this. Okay, what we have sketched before. Okay, so what I want to show you is, okay, so the domain here, okay, so basically it's from here, okay, at the y, sorry, at the z axis. Okay, you can see looking down, and it is located here. Okay, that is the domain. Alright, for the range, okay, so it's for the z axis also. Okay, so it's from 0 until 3 here. Okay, alright, so that is the difference lah between the previous here, the full range. Okay, here we have z squared plus y squared equal to 9, and also the equation here, that which is we consider only positive part. Okay,